Welcome to Beyond the Numbers. I am Omolola Astrop and I'm glad to have you here. Today we tackle SQL patterns that most people never get to, the Windows functions, where you have the rank, you have the dense rank, you have the sum over, and you have the lag. And by the end of this episode, you will understand how the four functions are being used and how the results they generate. The practice file is on the GitHub link in the description below. Download the file ep05_queries.sql, load it in dbeaver and follow along. A quick recap on what we did in the last tutorial. We discussed group by, which collapses rows into summary groups. We discussed having filters, which filters groups after aggregation. We also talked about where, which runs before grouping, and having runs after the grouping. Now look at the question on the screen. Which customers ranked in the top 5 by transaction value with their rank number shown? The next question says, what was the running total of deposits month by month? Then which month saw the biggest jump in deposits from the month before? Group by cannot answer these questions. You could only get the totals. But the rank function, and the running total, the month over month change, those require a different tool. That tool is Windows functions. And the reason group by cannot do it is the difference we're going to see in the next slide. So here is the fundamental difference. I want you to look at the screen. You have the group by and you have the window function. The group by collapses your rows. You start with 40 customers and you end with 8 states. The individual customers are gone from the results. The Windows function, on the other hand, it does not collapse anything. You start with 40 rows and you end with 40 rows. But each row now has a new column added to it, a rank, a running total, a comparison. That is what the new column does. And look at the two code blocks side by side. The group by query on the left runs 8 rows, 1 per state. So you can see that you have Lagos, you have Kano, you have Abuja, and it goes on like that. The window function query on the right side still runs 40 rows. Each customer has their own rank. Lagos customers have individual ranks. All 40 are still there. All the 40 customers are still on the table. The key insight at the bottom of this slide is worth writing down, which says a window function adds a new calculated column to each row without removing any rows. The original row count is always preserved. And that is the whole difference between the group by and the window function. Everything else follows from it. Moving to the next slide, you'll see that every function needs one thing, the over clause. Over defines the window which rows are included in the calculation for each row. Look at the syntax. Inside over, you can put 2 optional pieces. You have the partition by and you have the order by. What does partition by do? Partition by, what it does is it divides the rows into groups. The order by sorts the rows within the window. These 3 patterns these are the 3 patterns we're going to use this week. First, over with just order by. This ranks order across the entire result set. Every customer compared to every other customer, one global ranking. Then you have the second one, the other pattern we're going to use. You're going to see over with partition by and order by. This restarts the calculation for each group. Lagos has its own ranking, Kano has its own ranking, Abuja has its own as well. Then the third pattern is over with order by for running totals or lag. The order by tells SQL which direction to accumulate or which row to look back at. And you're going to see all the 3 patterns as we move on. Now look at this slide, 2 ranking functions and 1 important difference which I want you to note. If you look at the rank side, you see that if two customers tie for possible 2, both get rank 2, right? But the next customer gets rank 4, not rank 3. There's a gap where rank 3 would have been. That is rank, which ties it ties creates it kind of creates the gaps. So if it's grouping two people as rank 2, it's going to skip the 3 because of course one of them is 3, but in actual sense they are ranking the same. Now the right side, with the other side which has the dense rank, what it does is the same scenario. Two customers tie for position 2, both get rank 2, but the next customer gets rank 3. There's no gap, unlike when you use rank alone. So dense it doesn't have any spaces in between. The rule of thumb for this is you use rank when the gap matters, like a competition leaderboard where tied teams share a position and the next team drops below both. You use dense rank when you want a clean 1, 2, 3 sequence regardless of ties. So for most analytical work, customer rankings, product rankings, state rankings, dense rank is what you'd most likely use, or I would recommend. Now let's move to the first query question. The first query, business question. Which customers generated the most value in 2023? Ranked with their percentage share of the total. Now look at the query. Select name, state, sum of amount as total underscore value. Then rank over ordered by sum of amount in descending order. That is the ranking column. Then round of sum divided by sum over with empty parentheses. The last part, which I want you to pay attention to, the empty over, calculates the grand total across all groups. Dividing each customer's total by that grand total it gives you the percentage. From customers, join transactions where year equals 2023, right? Group by customer, order by the rank. If you look at the results, you see Opeyemi Olawale as the rank is in 1. The money is 46.2 million, the total amount. Then you have 15.9% of all 2023 value. The same thing for Danjuma Lawal. You see it there. You have the top 5 together equaling to 65% of everything. What this tells you as a data analyst is that concentration is a risk. The bank's 2023 revenue was driven by majorly 5 people out of 40 customers rather. So if Opeyemi closes her account, the bank loses 15.9% of transaction volume. That a VIP retention program for these 5 is not a nice to have, it's a risk management. So those are the things you start to tell your stakeholders if a data analyst based on the analysis you have done, that these 5 customers, they are so important. For us to manage the risk, we have to retain these 5 customers while we are looking for other ones as well. Moving forward, we move to the sum over function, which gives you a running total. Every row gets the sum of all previous rows plus its own. So look at the 2 examples we have side by side. On the left, the regular sum with group by, right? What it does is January shows 22 million, February shows 21.5. Each month stands alone. You cannot see how they accumulate. Now, if you look at the other side where you have the sum over, we said sum over, it's kind of do a kind of cumulative calculations. So on the right, you have January as 22 million, right? It remains the same. February moves forward to add the value of February to January, giving us 43.5. Then March moves forward again to join the value of January, February to March, and we have 64.7. So each row accumulates everything before it. How does this work? The order by inside over tells SQL to accumulate in date order. Without order by, sum over just puts the grand total on every row, which is useful for percentage calculations but not running totals. With order by, it runs forward through the sequence, adding as it goes on. Now the next business question. How did the bank's cumulative deposit intake grow month by month? And when did it cross the 100 million naira? If you look at this query, you're going to see that we select month number, month name, sum of amount as monthly total. Then sum of amount hover ordered by month number as cumulative total. The sum of sum pattern is important here. The inner sum groups deposits by month. That is what group by does. The outer sum over then accumulates those monthly totals in order. You need both in this instance. One without the other gives you the wrong result. So from transactions where year equals 2023 and TXN underscore type equals deposit, group by month, order by month number. If you look at the result which you have on the table, you'll see that January has 22 million and the cumulative is 22 million, right? By June, cumulative totals 107, which is well above the 100 million target that was given in the question. So the so what, then November pushes it significantly higher. So it goes higher like that. So what the so what is that the bank has crossed 100 million deposits in June, halfway through the year. For treasury planning, knowing when you cross key thresholds is as valuable as knowing the final total. So the treasury team can use this to time investment decisions. They know the heavy months and they plan for them. That is how a data analyst who is going to interpret that particular result. Then moving on, we have the lag. The lag reaches back to the previous row and pulls a value from it. This gives you period over period comparisons. The syntax lag, open brackets, column offset default value, close bracket, order by, over order by, date. Column is what you want to look back at. Offset is how many rows back. The default is 1. Default value is what to return when there is no previous row for the first row. So look at the results in the table that we have. January, which is previous month, is null. There is no December before it. Then we have February, previous month is January's value, and change is negative 510,000. Then November, the previous month for November is October, and change is positive 18 million. That change column is pure lag. Current value minus the lag of current value equals the difference. Where does this matter in practice? Month over month revenue. Which month grew fastest? Transaction frequency drops. Which customer transacted less in Q4 versus Q3? Then you have the dividend rates. How did the rate per share move between declarations? So anytime you need to compare something to its own past, lag is an essential tool to use. The business question we have here, which is the last one, which month in 2023 saw the biggest increase in deposits compared to the previous month? Look at the structure. The query has 2 parts. The CTE called month. It groups deposit by month for 2023, giving us a clean table of 12 rows, 1 row per month with the deposit total for that month. Then the outer query applies lag to that CTE result. Lag of deposits, 1 null, and this returns the previous month's deposits. Deposits minus lag returns the difference. Why use CTE here? Because lag on aggregated data inside a group by gets complicated fast, then the CTE does the group by first, then lag operates on those clean results. That separation kind of makes the logic readable. If you look at the result, you're going to see that November up to 10.5 million from October, that's the biggest single month jump, right? Then December went down 23.5 million from November. That's the sharpest drop. So the so what here is seasonal pattern is not random. It is quite predictable. November surges every year as bonuses arrive and businesses close the books. December falls as withdrawals happen for Christmas and year-end spending. So the Treasury team should plan for this cycle. They shouldn't be surprised by it every year. Now it's your turn. The task here is to use dense rank and partition by, rank customers within each state by their 2023 transaction value. You're going to show the name, the state, the total value, and their rank within that state. So there are two gaps for you to fill in the over clause. First, what goes in partition by, and what happens to your result if you remove partition by entirely. The second one is why dense rank and not just rank. What will change if two Lagos customers add exactly the same total value? Then run it and write your so what. Which state has the most competitive high value segment? What does that tell the bank about where to focus acquisition efforts? And I want you to post your answer in the comments. I promise I'm going to read everyone and respond to them. This is a summary of all what we have discussed, and I want you to come back to it every time while you are writing your window function, what the partition by does, what the lag does, what dense rank does. You have everything here, and I want you to take note of them. The golden rule here is that Windows functions run after group by rather, and you can combine them, group by to aggregate, over to rank or accumulate across these groups, and that is the sum of some pattern from query 2 that we discussed. In the next episode, we're going to apply all what we have discussed, and you're going to see how we move to the Power BI. So what you should expect in the next episode is we have discussed the dense rank, the rank. We have discussed quite a lot of things from episode 2 to 5. And the next episode you're going to be seeing is how to move from SQL to your Power BI and how you're going to develop your first dashboard. The 5 episodes of SQL that we have discussed in the past, you can now make them visible. You can connect your data to Power BI, build your first visuals, and produce a dashboard your stakeholders can actually read. So see you next time. Bye.